So in this capsule, we look at a new topic called isomers. So in the previous couple of things, we looked at how do we draw organic compounds. We looked at the loose dot structures, condensed structures, and skeletal structures. So you see here I have a lot of structures here. All of them are represented only in the skeletal fashion. So the title, for this short capsule is isomers. So we'll look at what are isomers and the different types of isomers. Okay? So isomers, by definition, are compounds that have the same molecular formula but different structures. As you see, molecular formula C4H10, I have written two different structures. Okay, so the first one is 1, 2, 3, 4, 4 carbons all connected to each other, which is we call a linear, a chain, a linear alkane. It's an alkane. It has only carbon-carbon single bonds. So it's a linear chain. Let's come to structure 2. A different compound, a different structure means a different compound, but it has the same molecular formula, C4H10. So let's take a look at this. Carbon, one carbon, second carbon, third carbon, fourth carbon. Okay. So 4 carbons, 10 hydrogens. So we are able to draw two different structures that have the same molecular formula. So this, and we call this compounds like this, branched. This is just a linear chain. That is a branched chain. So you have a chain going this way. Let's say carbon 1, carbon 2, carbon 3, carbon 4 branched off the carbon 2. So carbon 4 is called a branch. Okay, so terminology: linear chain versus a branched chain. Those two compounds are isomers of each other. Now when you talk about isomers, there are many different types of isomers. We are touching upon only one type in this video. And these two compounds are isomers in the broadest sense, but these two compounds are constitutional isomers. Remember there are other types of isomers? Constitutional isomers or positional isomers. Compounds 1 and 2 are constitutional isomers that have the same molecular formula. The only difference is the carbons are connected differently. Now, let's move on to the next molecular formula, C5H12. So, I need more space, so I will erase this bit here. Now, for C5H12, 5 carbons, 12 hydrogens, is the easiest one to write. So, if on an exam you are asked to draw the constitutional isomers or in general isomers of any given molecular formula, the easiest point to start is the straight chain linear alkane. So, this is a straight chain or linear, right? Straight chain or linear alkanes having 5 carbons. So carbon 1, 2, 3, 4, 5. And you can count the hydrogens. So there will be 12 hydrogens. I don't want to go into that because I have done that in the previous video. So C5H12 linear alkane. Okay. Now to draw the next constitutional isomer, what we do is cut down the 5 carbons to a 4 carbon chain. So I have drawn a 4 carbon chain here first. I have drawn the 4 carbon chain. That leaves one more carbon. So we need to add one more carbon because the molecular formula has 5 carbons, C5H12. This one is not C5H12. So one carbon is missing. So we need to add that one carbon. So if you add that one carbon to the end, then this structure and this structure are the same. So you cannot add it to the end carbon, but you can add it, the 5th carbon, on the 2nd carbon of the 4 carbon chain. So you have a new structure, a different structure, a different compound. So you see, this is a branched chain alkane. Has the same molecular formula as structure 1, C5H12, but a different structure. It's a constitutional isomer because the carbon changed positions from end to somewhere along the chain. This is a 4 carbon chain, 1, 2, 3, 4, and a branch at carbon 2. Okay. Now let's draw a different structure. So notice what I did. I have already drawn this thing. So I have a 4 carbon chain. If I number them exactly like this, 1, like if I'm numbering compound 3 or structure 3 as structure 2, I have carbon 1, carbon 2, carbon 3, carbon 4. Now you may see this. You'll notice this, right? The branch, comparing structure 2 and structure 3, in structure 2, the branch is at carbon 2 here. In structure 3, the branch is at carbon 3. So are these two structures, structure 2 and structure 3, different or are the same? They are the same. The reason being, we just numbered them differently. So if you go this way, 1, 2, 3, 4. You will notice suddenly structure 3 is no longer a different structure. It is the same as structure 2. The branch is off at carbon 2. Okay, so this is also structure 2. Although I wrote differently just to highlight that. So there's no structure 3. Different, you get the point, right? 2 and the whatever I wrote as 3 are identical. They're not different. Then, previously I had structure 4, so that becomes structure, a different structure, a different compound. Now, we started with a 5 carbon chain. We moved down to draw the constitutional isomers. We started with a 5 carbon chain, then moved down to 4 carbon chain and 1 carbon branch. Okay, and then continued on the 4 carbon chain, moved the carbon around, but then ended up with the same structure. So then we truncate the chain further. Now we have only 3 carbon chain, carbon 1, carbon 2, carbon 3. Okay. Now we need to put 2 carbons. Okay, 2 carbons. Now 2 carbons. Now you may think I'll add 1 carbon at this point. If you add a carbon at that point, for example, if I take that carbon away and add it there, then I have the same as 3 suddenly became 2. So we can't do that, right? So we are adding 2 carbons at carbon 3. Okay? So C1, C2, C3, C4, C5. Carbon 5. I'm discounting the carbons. So 5 carbons, 12 hydrogens. So that is a different structure. That's a unique structure. Okay? Now I'll draw one more. Okay? Before I go there, let me clean this up first. So structure, these two are the same, so I'll erase one. And erase all this. Now, one more trial to see if we can get any more constitutional isomers from this molecular formula. I'll start with a 3 carbon chain. So carbon 1, carbon 2, carbon 3, same as like 3, but I'm talking through this. Carbon 1, carbon 2, carbon 3, so we need to add 2 more carbons. In structure 3, we have added 2 CH3s, right? There are like 2 CH3s there. How about we add, instead of 2 CH3s, I add 2 carbons, but I add them like this, a CH2 and a CH3. Okay? That still satisfies the molecular formula C5H12. Okay? With this structure that I just drew is different from structure 3, but is it unique? Is it unique? Probably not. Let's see. So we have 3 structures now. So let's see if this one resembles any of those things. So if it is, then it's not a unique structure. So you see structure 2 here. Structure 2 has 4 carbons like this, C1, C2, C3, C4. What about this one? C1, C2, C3, C4. Okay, C1, C2, C3, C4. And C2 has a branch. C2 has a 1 carbon branch in structure 2. In this newly proposed structure, you have a 4 carbon chain and a branch, a 1 carbon branch at C2. Which means this structure that we just drew is identical to this. So it's not a unique structure. So we'll erase this. Okay. Now, I want to point out one more thing. Okay, so this molecular formula has 3 different isomers. They all differ from each other in the length of the chain and the placement of the other carbons. Okay, so they are positional isomers, they are constitutional isomers. Now, one more thing. I want to highlight this. So I'm drawing structure 1 again here. Okay. Now, I just want to point out this. Okay. These two represent the same compound, just that you wrote them differently. Okay. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Just different ways of representing the same structure, 1. Okay. Or you may think, I'll draw it like this. Okay. Is this unique? No, it is the same thing. C1, C2, C3, C4, C5. Okay. So you can draw the chain in a different way, like this, in different ways, but as long as the 5 carbons are connected to each other, it doesn't matter how you draw them. Okay. So all these structures, whatever one structure I wrote here, this one, this one, this one, are all the same compound, just shown differently. So these are not unique structures. So we have introduced constitutional isomers in this short video. Let's just do one more and then we'll stop it at that point. Okay. I want to move on to compounds, constitutional isomers with double bonds in them. So let's take C4H10. Molecular formula is C4H8. Okay. I'll draw the first one, carbon 1, carbon 2, carbon 3, carbon 4, and I put a double bond there. Okay. So we'll see C4H8, carbon 1 has 3 hydrogens, carbon 2 has 2 hydrogens, 1 hydrogen, 2 hydrogens there. See, so 3 plus 2, 5, plus 1, 6, plus 2 hydrogens there, 8 hydrogens total. So it satisfies the molecular formula, the structure. So C4H8. Now, this is one compound. It's a unique compound. Let's try another one. Now we will move the double bond, the location of the double bond, to in between carbons 2 and 3. Okay. So the double bond location has changed. These two structures are constitutional isomers. one more compound. Let's see, C4H8. What about this one? There are 4 carbons. Each carbon has 2 hydrogens. So this is also a constitutional isomer. So now we have not talked about functional groups as such so far, but the functional group here, we are saying compounds with double bonds or alkenes. So the functional group is the double bond functional group. Functional group, the name denotes it's a function, it has a function in the structure. So the functional group in these 2 compounds is alkene because it has a double bond. Okay. So you are noticing something now. Constitutional isomers may have different structures. Of course they'll have different structures, right? They are constitutional isomers, but the important thing to note is that they are not limited to one functional group. So you see there's alkenes there, and here you have a cycloalkane. It's a different functional group. Now, one more thing and then we'll stop. I'm saying that and continuing. So, one more thing, final thing for this video, and which is often seen in textbooks, is this particular molecule, C2H6O. So we are bringing oxygens into the mix. C2H6O. Okay. So I'll draw one structure, CH3, CH2OH. So that is the CH3, CH2OH. Okay, that's one structure. Another one is CH3O, CH3. So this is CH3O, CH3. I just, often abbreviated like that, right? Skeletal structure. So again, different functional groups. Compounds that have a carbon connected to a OH group, carbon connected to an OH group are called alcohols. So that's a new functional group for us. And in this one, in this structure, you see a carbon connected to an oxygen connected to a carbon. Compounds like this are called ethers. So, same molecular formula, different structures, and those structures belong to different functional groups. Just to highlight different possibilities. Good. We stop now.